This lesson is on section 3.4. It begins on page 342, and this lesson really is about two different concepts. The first concept is what we call the library of functions. You will also hear these called parent functions. These are the basic functions that we have or that we use in algebra, and the concept is that they're so commonly used we should recognize them and know what their shape is just by virtue of what they are. So they begin on page 242 with example 1, and if we were in class, what I would have you do is to create a table of values to show each function. So we would make an XY chart and we would plot some points. The first one being the cube root function. And when we plotted those points, they might look something like this. And we would get this kind of a graph when we plotted the points. And so what I need you to know is that if you see the function y equals the cube root of x, that it has this kind of a shape. The second one is the absolute value function. And so they've shown you down on the bottom of page 243 how they've substituted in some points and graphed those points. It continues. No, it doesn't. But they don't show you, but they did graph negative points. It's just not shown in this table of values. So I would want you to know that if you see the function y equals the absolute value of x, that it's going to be a V shape with a square corner right here. The third one is what we call the constant function, and that would just be y equals a number, and we've talked about that in the past, and it's just a straight horizontal line. Then we have y equals x. We call it the identity function, and it graphs all the points 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, any value where y equals x, and you get this line that's at a 45-degree angle and goes through the point 0, 0. Then we have the square function, and it's y equals x squared. You know f of x is just another name for y, so that's y equals x squared, and if you created a table of values and plotted those points, you would get this, because 1 squared is 1, and 2 squared is 4, negative 2 squared is 4, etc. So you would get those points. Then the next one is called the cube function. I'm on page 245 now, and they don't show you the table of values here, but it would be the same thing. You make a table of values, and you get this sort of S-shaped curve that goes through the point 0, 0. Then we have the square root function, and this one's unique in that it only extends in one direction. You see this point right here is fixed, and then it goes to the right, and the reason is you can't use any negative values for x if you're going to substitute it into the square root, because you can't take the square root of a negative number. So that's why it starts at 0 and goes to the right. We've already mentioned the cube root. That was the first one we looked at. And then we have the reciprocal function, y equals 1 over x. And that one is unique in that it has what we call asymptotes. And this is the word I'm saying. Asymptote. An asymptote is a line that a graph gets closer and closer and closer to, but never touches. And so this line is an asymptote, the y-axis, and the x-axis is an asymptote. So it gets closer to the y-axis as you go up this way. It gets closer to the x-axis as you come down this way. The same thing over here, closer to the x, closer to the y. So you have these two little pieces. The unique thing about this one is it doesn't have any intercepts. It doesn't hit the x-axis, it doesn't hit the y-axis. And the other unique thing about it is that its domain and range are unique in that it's everything except 0. So it's all real, they say it is all non-zero real numbers. All real numbers except 0. We talked about the absolute value function. And then the last one that's on page 246 is what's called the greatest integer function. And it has a very unusual looking graph. It looks like this. We won't be doing much work. In fact, we won't be doing any work with the greatest integer function, but it does look like this. It's also called a step function, and you can see why, because it looks like little stair steps going up. But that is part of the library of functions. So when we get to the homework, the first part of it is simply matching. They want you to be able to identify the shape of these. So this one is the square root function, because remember it starts at 0 and it goes up. This one's absolute value because it makes a V. This is the reciprocal function. This is the cube function, and this one's the cube root. The cube root's laying on its side more. This is the constant function, this is the square function, and this is the identity function. So the purpose of the first group of exercises is to just make you match up the name of the function with the shape of the graph. And that's all you have to do with that part. Then the next part is actually to draw a couple of the graphs. And so number 19 is y equals x. So what you would do, even though we know what it looks like, you would make a table of values, and it's y equals x. So whatever x is, y is. And if you were to plot those points on a graph, -3, -3, -2, -2, -1, 0, 1, 1, 2, 2, 3, 3, you would get that 45-degree line that I mentioned a while ago. That's called the identity function. And that's what it would look like. Then maybe you were asked to do number 23, whose graph is y equals the reciprocal of x. So let's see what happens on that one when we create a table of values. If you let x be -3, then y would be -1/3. -2 would be -1/2. -1 would be -1. Remember we said we can't do 0 because you can't divide by 0, so that's not a possibility. 1/1 is 1, 1/2 is 1/2, 1/3 is 1/3. And when you plot those points, this is what happens. You have -3, -1/3. Whoops, you can't see that, can you? Where am I? There I am. Okay. -3, -1/3. -2, -1/2. -1, -1. I'm plotting those points right here that I just created in this table of values. Then I have 1, 1. At 2, it's 1/2. And at 3, it's 1/3. Well, that's not enough to really know what's happening. So what you have to do is to do a few fractions. For example, if you let x be 1/4, the reciprocal of 1/4 would be 4. If you let x be 1/2, the reciprocal of 1/2 would be 2. And the same thing for the negative values. If you let x be negative 1/4, the reciprocal would be negative 4. And if you let x be negative 1/2, the reciprocal would be negative 2. So we're going to add those points in. 1/4, 1, 2, 3, 4. You can see it's going way up here. 1/2 is 2. At negative 1/4, it was 1, 2, 3, negative 4. And at negative 1/2, it was negative 2. And that's how we get that curve in there, is using those fractional values. And so it comes closer to both axes like that, but it never actually touches either axis. And that's the reciprocal function. All right. And that's the essence of the library of functions or parent functions. Now, the second part of this lesson is what we call piecewise defined functions. Piecewise defined functions. And what that means is you have a function that has multiple rules for different parts of its domain. I'm going to look excuse me, at number 27, and it says f of x equals, remember f of x is just another name for y, and it's got 3 different rules. The opposite of x squared, if x is less than 0, 4 if x equals 0, and 3x minus 2 if x is greater than 0. And the first part of this group of problems is to evaluate. So you see on number 27, part A asks me to find f of negative 3. So what I have to decide is, in this group right here, where does negative 3 fit? Does it satisfy this, or this, or this? Well, you know that negative 3 is less than 0. So what that tells me is that for negative 3, I need to use this part of the rule. So it would be the opposite of negative 3 squared, which is the opposite of 9, or negative 9. So my answer would be negative 9. Part B of this asks me to find f of 0. So you have to decide, where does 0 fit in this list of rules? Well, certainly it's equal to 0, so my rule says the answer is 4. For part C, it's f of positive 3. Well, where does positive 3 fit? It's in the group that's greater than 0. So I use the rule 3x minus 2. You put this 3 in the place of the x. And my answer is 7. So a piecewise defined has multiple rules for different parts of the domain. And you have to see, if you're evaluating it, where it fits to know which one of the rules to use. All right, the next one we're looking at is number 29. And they want me to find f of negative. Why is this not working very well? Let me see if I can adjust this. Okay. So here's my function. That was copied out of the book, number 29. And first part A is to find f of negative 2. So, does negative 2 come between negative 3 and 1? Or does it come between 1 and 5? Well, yeah, it comes up here. So that means I'm going to use this rule, 2x plus 4. And I put this number in the place of the x. So my answer is 0. Part B is to find f of 0. So where does 0 fit? Is it between here, negative 3 and 1? Is it between 1 and 5? Well, you know it's between negative 3 and 1. So again, I use this rule. And I put the 0 in the place of the x. Part C is to find f of 1. So I see 1 in both places, so I have to figure out which one can be equal to 1. Well, you see you've got the equal to here, you don't have it here. So that means if it's actually equal to 1, I need to use this rule, the 2x plus 4. And then finally, part D is f of 3. Well, 3 comes between 1 and 5. So that tells me to use this rule, which is x cubed minus 1. And I put this number in the place of the x. So that's 27 minus 1. And my answer is 26. Now, that's the group of problems on evaluating. Given a piecewise function, find some evaluations of them. Next, I'm on page 251. Whoops, 251 right here. And this group, we have to find the domain, we have to locate any intercepts, we graph it, and based on the graph, find the range. Well, my thought is it's easier to do the graph first, and then we can talk about all that other stuff. So number 31 is f of x equals 2x if x is not 0, and it equals 1 if x is 0. Now, what I find useful is to make a table of values, one for each rule. So this rule says if x is anything except 0, I'm going to use y equals 2x. So that means if it's negative 3, I'm going to multiply by 2 and get negative 6. If it's negative 1, I'm going to multiply by 2 and get negative 2. It says don't use 0. If it's positive 2, I'm going to multiply by 2 and get 4. If it's 4, I'm going to multiply by 2 and get 8. This one says I only have one value I can use. When x is 0, y is 1. That's it. That has 1 point. Alright, so now let's see how we put this stuff on a graph. Let's see if I can get all this going on here at the same time. There we go. So I'm going to plot these points. Negative 3, 1, 2, 3, 4, 5, 6. Negative 1, negative 2. 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. And normally you connect all those with a straight line. But remember, it said it can't be 0. And so what you have to do is you do connect it with a straight line. But right here where x is 0, you put an open circle. I missed my point right there, but y'all see how it should go like that. So if something's left out, you show that by an open circle. And then we're going to graph the other point when x is 0, y is 1. So we put that one single dot right there. Now, let's go back and answer all the other questions. The first question is find the domain. I find it easier to think about a number line. This part of the rule takes care of everything except 0. So where 0 is, there would be an open circle. So it takes care of all that. It takes care of all that. X equals 0 means I now close this in. So you see I've taken care of the entire x-axis. So for that reason, my domain is from negative infinity to positive infinity, all real numbers. The second part is to list the intercepts. Well, let's go back to the graph. Where does it hit the x-axis? Nowhere, because there's the only place it could, there's an open circle. So this one has no x-intercept. Where does it hit the y-axis? Right here at 1. So its only intercept would be the point 0, 1. Okay? Now, the third question is, based on the graph, find the range. What you're doing when you find the range is you're trying to say all the y's come between here and here. So like if I had 2 pieces of little spaghetti, if I could box it in and say all the y's come between here and here, well, this one keeps on going and this one keeps on going. So there's no boxing it in. And this point right here that wasn't included in the x-axis, it does have a point up here. So the only thing that y can't be is 0. There's nowhere on this graph where y is 0 because of that open circle. So the way you write it to include everything except 0, think about what it would be on a number line. If you were doing a vertical number line and you're going to leave out the number 0, you would include all of this and all of this. So it goes from negative infinity up to 0 with an open circle because 0 is not included. Then it starts at 0 again and goes to positive infinity. And then you put the little union symbol right there. That means or. It means the y values are down here or they're up here. And that would be the range. And let's see. That's the last part of that. Okay? Alright, let's do another one. I'm going to do number 34. That has this graph, or excuse me, this rule. That's a minus, sorry, that's a minus. I can't even copy. Okay, so I'm going to make me 2 table of values. I'm going to have one for x plus 3. And I'm going to have 1 for negative 2x minus 3. For this one, I'm going to choose values of x that are less than negative 2. Okay? So maybe negative 4, negative 3, negative 5. And since negative 2 is a barrier point, I'm going to put it there, although I know that's going to be an open circle on my graph because it doesn't say it's equal to negative 2. But you do need to put that final point because it needs to go all the way up to there. So my rule says x plus 3. So all I need to do is to add 3 to those numbers. Now this rule says pick numbers that are greater than or equal to negative 2. Well, my barrier point is negative 2, but it's included because it has the equal to there. And then I'm going to pick some numbers that are bigger than negative 2. And the rule is negative 2x minus 3, so that would be 4 minus 3, 2 minus 3, 0 minus 3, negative 2 minus 3, and negative 4 minus 3. Now I'm going to transfer those points to my graph. So I have the point negative 4, 1, 2, 3, 4, negative 1, negative 3, 0, negative 5, negative 2, and negative 2, positive 1, with an open circle. So this rule, this rule said that x had to be less than negative 2. That means this is a barrier. Nothing on the side of the ruler exists. Only what's to the left of the ruler. So it starts here and comes down this way. Because x had to be less than negative 2, there's no part of this over here for that rule, for the x plus 3 rule. Now, for the other points, I can't figure out how to make you see all this, but anyway, negative 2, positive 1. Well, I had that point, but it was a closed circle. Well, it's kind of like rock, paper, scissors. A closed circle always wins over an open circle. So if you have the same point, one's open and one's closed, you make it closed. Alright, and then my next point was negative 1, negative 2, and then 0, negative 3, and 1, 1, 2, 3, 4, 5, and 2, negative 7. So now, this rule was for parts of x that are greater than negative 2. So it's only from here over. So I draw this line and connect those points, and it looks like that. And that's my graph. It's not a very straight graph. Why is that? Because this point was supposed to be right here. Okay, that's why it's crooked. I computed that one wrong. Okay, it looks like that. Now, the first thing says to talk about the domain. Alright, well, let's look. If you think about the x-axis, my barrier point was at negative 2. This one says everything less than negative 2. This one says including negative 2 and everything to the right. So that covers up the whole thing. So my domain is going to be all real numbers again, which is negative infinity to positive infinity. All right, the next question is to find the intercepts. All right, let's go to the graph. I have to figure out where it crosses the x-axis and the y-axis. Well, I see right here that it crosses this x-axis at -3. See that? So -3, 0 is an x-intercept. I also see it crosses right here, but I can't really tell what that number is. So I think about what that equation was. The equation for that part of the line was -2x minus 3. So when does -2x minus 3 equals 0? Remember, to find the x-intercept, you let y be 0 and solve for x. So I get -3 halves. -1 1/2. So that's about right there. So that's another x-intercept. -3 halves and 0. And then for my y-intercept, where does it hit the y-axis? That's right here at -3. So that would be 0, -3. So I would type all of those in for my intercepts. Now, one thing that I have seen happening, the directions say put a comma between the points, and some of you are leaving out the comma or you're typing in a period, and that's what's causing you to miss this kind of question. So the way you would type this in is a comma there, a comma there, like that. When I was looking at some of your quiz answers, your midterm answers, you missed this kind of question because you either hit the period or you left out the comma. Well, I went back and gave you credit for it because I could tell what you were doing. But be careful about how you type that in, because that's one of the things that's causing you to miss stuff. All right, the last part is, what is the range? Okay, we want to know, can we box it in? Can we take our little pieces of spaghetti and box it in and say the y's come between here and here? All right, we'll see right there, there are no y values above that. Nothing above that. But see this part, this keeps on going. So this one's going to go to -infinity up to whatever that is, and that's 1. So my range for this one would start at -infinity, that's down here at the bottom, and go up to the y value of 1 with the bracket because it's actually equal to 1. So that would be the range for that one. Alright, let's go on to number 35. Whew, sorry. Alright, so I'm going to make 3 tables of values. 1 for x plus 3, y equals x plus 3. 1 for y equals 5. And 1 for y equals -x plus 2. Alright, for the x plus 3, I'm supposed to use values between -2 and 1. Now remember, I told you to be sure you use any of the boundary points. So we'll want to be sure we use -2 and 1. And then we'll want to use anything between that, which could be 0 and -1. So I substituted into here. -2 plus 3. 1 plus 3, 0 plus 3, -1 plus 3. And since this one's not included, I know this one's going to be an open circle. Alright, for y equals 5, I have only 1 point. When x is 1, y is 5. The end. For this one, anything bigger than 1, I want to include 1 because I want to use that boundary point, but then the main points I'm going to have are going to be bigger than 1. So the opposite of 1 plus 2, the opposite of 2 plus 2, the opposite of 3 plus 2, and the opposite of 4 plus 2. Okay? Now I need to take graph paper and put all of that on it. Let's see if there's any way I can show you the points in the graph at the same time. Sort of. Alright, so -2, +1, 1, 1, 2, 3, 4, 0, 1, 2, 3, and -1, +2. Now remember my 1, 4, that's going to be an open circle. And this one, the domain is clearly defined. I mean, the interval part is clearly defined. You can't go beyond those. So this one doesn't go on forever. It just goes there and it stops. That's it. That's all there is. Alright, for this one, when x is 1, 1, 2, 3, 4, 5, I have this point. And for this one, I have 1, 1, 2, 0, 3, -1, 1, 2, 3, 4, -2. Now this one said x is greater than 1, meaning it includes all of these values. So once it starts here, it goes on forever, because it's not bounded on both ends like this one was. Alright, so now what is the domain? Alright, I think it's easier to come back and let's look at a number line. We've got -2 and 1. The first rule gave me instructions for including -2 up to 1. The second rule gave me instructions for 1, so now it's included. My third rule gave me instructions for x is greater than 1. So I've got everything colored in from here over. So my domain starts at -2 and goes to positive infinity. It doesn't go this way. There's a definite beginning place and then it goes to the right. So that's my domain. The next part was the intercepts. Well, we can see it hits the y-axis right here. So that would be the point 0, 3. And it hits the x-axis right here. That would be the point 2, 0. But it also hits the y-axis right here. So that would be the point 1, 0, 5. I didn't do that right, did I? That's not supposed to be there. Sorry about that. That point, I didn't graph that point right. That was my fault. Let's go back. It was 1, 5, not 0, 5. I should have gone 1, 1, 2, 3, 4, 5. It should be that point right there. Okay? Okay, because it can't have more than one y-intercept. So that's it. So I have this y-intercept and this x-intercept. Now, for the range, where did my spaghetti go? Can I box it in? Can I say it's between here and here? Well, I can see that the highest point is 5, but there's not anything in between 4 and 5. So I got to leave that part out. Then when I get to 4, it doesn't include 4 because, see, I got that open circle, but it includes everything after that. And this one takes over where that one leaves off, and so it keeps coming on down for all my y values. So, this is what I would write for the range. It includes the number 5, and there are two schools of thought here. One is to do it like that, and one is to do it, you start and stop at 5. I need to look that up and see which one is the preference, and I'll tell you in the Zoom meeting tonight which one it is. And then we're going to combine that with negative infinity all the way up to 4. See, remember, it was going to start down here at negative infinity and go all the way up to 4, but it doesn't include 4. So I'll put a parenthesis there. So my range could be that or this. And I'll need to make me a note that I need to look that up and let you know in the Zoom meeting tonight which is the preferred way to write that. But that's the range. And the question is about how you do it when it's a single number. Okay? Alright, let's do one more. Number 39. Alright, so two table of values again. This one's for the absolute value of x. This one's for x cubed. Alright, I can only use numbers between -2 and 0. So it's going to look like that. And I'm going to take the absolute value of them. But I'm helped by the fact that I know that the absolute value function looks like this, a v. And it stops at 0, so I'm going to include, it's going to be like this much of it, from here to here. I'll show you that on a graph in just a minute. And then y equals x cubed, remember when we had the parent functions? It looks like this. It goes through 0, 0. And this is everything greater than 0. So it's going to be this part of the function. So if x is 0, I get 0, 1 is 1, 2 is 8. Because I cube it. So 2 cubed is 8. I could have the point 327, but that's not going to fit on my graph. But I know that it's going to go way up here, head toward 27. Alright, so let's see what we got. -2, +2, -2, +1, and 0, 0. Now, it didn't include the 0, so there's my open circle right there. It did include the 2, but that's it. Nowhere beyond those, so it's just that one little segment, and that's all. Alright, then for x cubed, Did neither one of those include 0? Let me make sure. No, it didn't. Okay. 0, 0 is also an open point because it didn't include that right here. Then I have the point 1, 1, and 2, 1, 2, 3, 4, 5, 6, 7, 8. So it comes up like this, like it's that part of that S curve. Okay? All right. Domain. I got to talk about -2 and I got to talk about 0. This is from -2 to 0, includes -2, and stops at 0 with an open circle. This one is greater than 0, so it starts at 0 with an open circle and goes to the right. So my domain is going to have to be written in two parts, from here to here, and from here to here. So I use a bracket -2 with a parenthesis on the 0 because it's not included. Then I start again and go from 0 to positive infinity. Again with the bracket because the 0 is left out. And you put the little OR symbol or union symbol right there in between them. So that's my domain. The next question is the intercepts. Well, let's look at this graph. The only place that it could have a potential for an intercept is right there, but that's an open circle. So that means this graph has no intercepts at all. Then for the range. Alright, can I block it in? Can I say all the y values come between here and here? Remember, this one's going on forever because it just said greater than 0. So I know that one's going to be positive infinity. Alright, where does it start down here? Well, it starts at 0. See, there's nothing down here. It starts at 0, but it doesn't include the 0 because it's an open circle. So for the range, I'm going to start at 0 with a parenthesis because it's not included, and then I'm going to go all the way to positive infinity for the range. Alright, so that's the last part of this lesson. So you have the library of functions, you have evaluating piecewise, and then you have graphing piecewise. And that's the end of section 3.4.